The broadcast is now starting. All attendees are in listen-only mode.
All right. Would like to welcome everyone back to another KevCAM night class tonight. And I suppose I better turn my screen on so you guys can see it. There we go. I want to welcome back to another KevCAM night class tonight. Tonight, can't do a class from now on without having Greg in here. So Greg, are you with us?
Good evening, everybody.
All right. So I do see a lot of regulars in here, so I'm not going to go through the boring introduction, and we will just get the ball rolling tonight. Something kind of neat, interesting, maybe something that you're not going to use a whole lot, but after showing you how to do the HSS, the user-defined projection, may shed light on some areas where you can do this in the future, as in doing like a pencil pass or maybe a cleanup pass or something like that. So that being said, we will get the ball rolling with our HSS user-defined projection. So first, I got a part here, and let me get this this part finished off because I see I just have a 3D machine. So I'm just going to do a quick linear cut here, and my drive surface is the surface I want to cut. So this may be a little bit of repeat for some of you guys. And we'll go ahead and use our ball end mill. And
yeah, it feels like it's been ages since we did the HSS linear class.
Yeah, it sure
so this
does.
will be a good refresher.
Yep. All right, so we got a nice linear tool path on there. I got some jumping up and down on our ends, as well as square corners not blending real nice. So we're going to go to our link section, links, and I'm going to tell small moves to do a blend spline, as well as large moves, or links between slices. So clean up our tool path, and all right, we're good. So now we are up to a surface finish stage right here. Now, if we wanted to cut an O-ring groove in here, or as well as using like a part number, or if you're doing any kind of engraving, this is where HSS projection really shines. And for those of you guys, we're going to go way back here when we were talking about 3D engraving. Now, this is pretty much the same thing as 3D engraving, or I should say HSS projection is 3D engraving, because what you're doing is you're clicking on a sketch, and what it does is it projects it down onto the surface and follows the contour of that surface for you guys. So let's go ahead and open up our HSS here, and you'll find it at the very bottom, and we're going to do user defined. Now, I should kind of explain what user defined is. So the strategy projects the curve of a selected in the projection curve selection down on the drive surface. So in machinist terms, we're going to take this sketch and project it right onto a 3D contoured surface. So drive surface, what do we want it to be projected onto? So we want to project that sketch onto that surface. And then for this particular one, we are going to do the direction in the z-axis. Now the curve is what do you want the end mill to follow. So we're going to tell it to follow that sketch. And since what it will be doing here is we'll be projecting, doing a ball end mill going right along the sketch line. Now, if we're doing like an O-ring groove or something like that, we're probably going to want to go just a little bit deeper. So with my surface offset here, I'm going to tell it we want to go -5. So it's that ball end mill is going to be going into the material by 5 thou. Okay. Now, grab a tool. Like I said, kind of think of this as almost like pencil milling, just following one pass. I'll show you some cleanup passes on the next part here. And that is it. So just kind of recap here. Drive surface is the surface that we want to project it onto. The projection curve is the sketch that we want to use for the projection. The max projection distance is the distance. If you had multiple layers of different sketches here, what you could do is you could filter out some of those sketch lines based off of the max projection distance. Since this projection is, it's got to be within 5 thou of the max distance here, it's going to throw it on there. Now, like I said, if we had more up on top, it would filter those out for you guys. And then grabbing our tool, and that is it. Save and calculate, and we get kind of a top-down view or isometric view here. You can see the tool path is following along the curvature of the surface to a T. So let's go ahead and simulate this here. Take a second to update because I created that linear path. I must have my tolerance set pretty tight because it's taking a little bit here. All right. So here's what it looks like after my linear HSS linear path went through there. Now, if I could slow this down a little bit, we can watch our tool make, like I said, O-ring groove. If you want to do some kind of tracing, anything like that is really where projection comes in handy. So just doing one single line. Now, normally if we were to do this, what we need to do is we would need to model it up in SolidWorks and get that O-ring groove in there. So this is eliminating all that work of having to do a cut sweep, following the curvature and all that in there, and you can do it right inside the software. So like I said, all you just need is that simple sketch, and it will project it on there automatically for you guys. Any questions on this part? Or Greg, do you got something that we could?
No, I may have something towards the end, but so far so good, and no questions coming from the questions panel.
Excellent. All right, so let's go ahead and hop over to another part here. And close out of here. All right, so this is kind of where I was talking about cleaning up corners, or almost like a single line pencil path just to clean up. So on this one, we want to just clean up the bottom radius along here. So once again, we are going to do our HSS projection user defined. My geometry is going to be my chamfer going around here, or radius. And then my projected curve is going to be following along this bottom half right here. So that's kind of my guide curve, or that's the way I want the toolpath to follow. All right, and then I'm trying to think. Nope, I think this is good. And now this is basically a 2D part, so it's not really doing any up and down movement, just kind of cleaning up that last fillet along there. Grab our end mill, and we'll go ahead and save and calculate here. Let's go ahead and simulate this. And our tool just does a simple, easy move, cleaning out those areas for us. And if we go ahead and turn our stock target comparison, we can see that we're right up to size, cleaning out that material that was previously left over from a previous op. So keep that in mind when you guys are doing this. Like I said, projection user find is not one that I use a whole lot. But as I was kind of going through the class material, it's like, oh man, I could have used it on this part here and save myself a little bit of time. So definitely kind of keep that in the back of your mind too. All right. So now let's take this same part and do 3D motion here. So let's go here. So we got a little bit of a smaller radius with not so nice of a blend in a larger radius, as well as a smaller radius over here. So same thing as what we talked about before is our geometry will be the fillet here. The curve that I want it to follow and then just our tool. And you can see we got exactly following along there. Now, remember the tool path that is being shown is the center of the ball coming along here. So when we come straight down and start feeding down for this last little bit, we might be hitting material. So at this point, something we don't talk about a whole lot with HSS, but having your lead in and lead out. So we can set up a lead in, lead out. And now you can see that we're kind of, get a little side shot here. We're coming in from the side, doing a vertical tangent arc as we arc into the material and start moving across. And hopefully you guys can see that we're not doing a 2D surface here, we're actually doing a 3D, so all X, Y, and Z axes will be going simultaneously through there to get that cut. So like I said, it's not something that gets used a whole lot, but definitely hope this kind of helps shed some light for everyone as well. Okay, Greg, what you got?
Wanted to bring up that the HSS user-defined projection can be used in some cases as a manual toolpath of sorts.
Yeah.
As we saw with the first example where we're driving it along a SolidWorks sketch, you don't have to actually project that to a surface feature on a model. You can actually use SolidWorks surfaces that are based off of that sketch and drive that toolpath along a desired sketch line, regardless of the surfaces around it. So I've seen some creative uses of this in the past, especially with the counterpart in the simultaneous 5-axis, where we're using the HSS user-defined projection, but with rotary motion involved with it. There's a lot of interesting things that you can do with this type of toolpath that wouldn't be possible with other style toolpaths. So,
yeah, absolutely. I mean, even on a part like this, so if we came in here, cleaned up this radius, and if we want to kind of come in here and do this radius following along here, we could also do that. Throw some path on that real quick. And our curve. There we go. So we can see that ball end mill kind of curving down and then working its way through, getting that cut out of there and coming back through. So smaller radiuses definitely help as well, or it will help you guys out as well in there. Kind of wish I had more to show you guys, but I think that's everything that I planned for tonight. So again, it's going to take a little bit longer than 15 minutes, but.
Now, you were bringing up earlier about the differences between like a 3D engraving and a user-defined projection. Maybe we can touch on some of those since they share some overlap.
Let's go back to that part here. Now, one thing completely off subject, has nothing to do with HSS or not, but I'm going to bring this up because I'm fighting it right now as I'm doing the night class. Greg's like, oh boy, what's going on here? I'm going to show you guys something that Greg got me stuck on it, and I was for surely not going to ever get one. But for those of you guys that use a mouse, which pretty much everybody does, this mouse, I don't even know what they sell for. What do they go for? Like $100, 119 bucks, worth every single penny. The reason I say that is I'm bouncing between two computers, and this computer I don't have it, the other computer I do, and but they got it set up for right hand, left hand. This is no sponsor or anything like that. If you guys are doing a lot of modeling, doing a lot of CAM, this will make your life a whole lot easier. All right, we'll get back to the topic.
Yeah, I absolutely love mine for all the traveling that I do.
Yeah.
Yeah, and the way that you can select between USB mode and Bluetooth mode works quite nicely.
All right, so let's go to that sketch. All right, so we got a sketch on there. Let's go ahead and add and let's go font. Now, for those of you guys that do engraving or any kind of lettering and stuff, DPS Shrift, that's your kind of your go-to. Does a really nice single line font. No, let's gotta get bigger than that. And that's not gonna let me oh, we'll keep it right there for right now. We don't have to put another sketch on there. All right, so kind of the differences between the two. And I do see we got a question in there asking if we can offset it, and absolutely. So we can see that our sketch is not even close to our surface there. I don't have to do any work inside SolidWorks. And to kind of get with Brock's question here, let me get to our HSS projection. So if you want to offset it 10 thou, 5 thou, whatever that you're looking for. So right now we are currently telling it to do a negative offset of -5. But if we want to go something larger, like 15 thou, which is going to be a gouge into your model. So if you are using gouge check, it's not going to work out so well, because if you do a gouge check against the drive, we're trying to drive that tool through there. So now let's go ahead and just do a quick simulate here. And we can see that that tool is going way, well, not way in there, but deeper than the 5 thou that was before. Now, if you're just looking to, like we're talking on the other parts, just looking to do a kind of a cleanup pass, put 0 in there, solid verify, and we'll still see a little bit of remnants of there, just because our linear pass was going this way, but like especially when we're changing orientation with that tool, so you will see a little bit of marking on there, but you can see it's just going along right along that drive surface and cutting in there. So we were talking about 3D engraving. Oops. Now, basically the exact same thing. So we'll do a comparison here. So let's do 3D engraving. So switch it over to 3D. It's asking me for the text. So I'm gonna go to my multi-chain text, grab my SolidCAM, accept that. And we'll just use that same tool, which was tool 3. Levels. So upper level, top of the part, we could just put 0. Lower level, that's fine. My engraving depth, I want to be 5 thou. Technology, I want the tool to follow the center. Save and calculate. And let's go ahead and see what that looks like. Speed it up here. So you get nice, clean, SolidCAM cut going through there. I mean, I could spaced out my letters a little bit more here, but gives you guys a good example. Now, HSS is going to be should be the exact same thing. So, user defined, drive surface. What do we want to project? That same text as we grabbed before. So we're going to do add multi-chain text. Go ahead and hit the green check mark. Green check mark. And drive surface offset. Do minus 0.010 thou on this one. Save and calculate. So we can see the SolidCAM from our previous 3D milling. Now this one should be going a little bit deeper, but exact same thing. So if you guys are looking to do any kind of engraving on there, like I said, you can put it on the craziest surface and it's going to follow it right to a T. And kind of getting like with Brock's question, you know, I can go to my geometry, I can put it at a +1 inch, I can tell it to go way down deep inside there. The sky's the limit on what you guys can do. So if we do like a -0.1, I don't recommend because it may break your ball end mill. You can see we're going much deeper in there if you're looking for a little bit heavier cut. So, any questions from anybody? Oh, go ahead.
Well, one of the things you're going to see between the two, the 3D engraving and the HSS user-defined projection, is that you have a lot more options when it comes to the HSS operation. We didn't really touch upon it with these parts, but gouge checking. You mentioned gouge checking against the drive surface. You're not going to get any toolpath. But if you are going to put any kind of like texturing on a part that has an organic surface, say you want to put some checkering on something, you can use the HS user defined, and you can also use the 3D engraving. But if you find that you have like an extruded boss that's coming up through that surface, you can actually use the surfaces of that extruded boss in your gouge check on the HSS variant, and that way the toolpath will automatically either retract the tool and go around that boss and then back into the material, or you can set up a variety of different options within your gouge check, but you don't have to make any special provisions for that geometry that you normally would if you were using the 3D engraving.
Yeah, great point. And on top of that, if you guys have a toe clamp or part of your fixture in the way or a bolt that's in the way, you can use that as your check surface as well to avoid that too. So yeah, didn't even think about that one. Any other questions from anybody out there? Well, I had one come through, so it's a pretty easy night.
And we verified that the question system works.
Yeah, exactly. The winner, whoever writes a question in there gets a Tootsie Roll. No, All right, so that kind of wraps up everything that I have for the user-defined projection. Now, next week, I will be out of the office doing on-site training in Pennsylvania, and Greg is, I'm sure, somewhere. But so we won't have one next week, but the week after, March 30th, we will go on to the HSS projection radial, and then we'll keep working through our projections. And after the 13th, we will finally be done with HSS. So for those of you guys that are sick of hearing the HSS, it will be done. We'll close the chapter on the HSS, and we're going to get into some pretty cool mill turn stuff that I want to show you guys. So, but I just want to thank everyone for joining the night class. These classes are dedicated for you guys. So if you guys do have an idea, send those ideas over to me via email, and I'll get those added in there right away. If there's something you want to see changed in there, you know, we'll do whatever you guys need to really learn the software and to be there to help you guys out. So, all right. With that being said, if I don't talk to you guys in the meantime, we will talk to you guys in 2 weeks on March 30th to cover the projection radial. All right, everyone. Have a great rest of your evening. Bye-bye.
Good night.